Welcome to P.U.R.E. Physics. Today we're going to see chapter number 2, Kinematics of Class 11 Physics Tamil Nadu Board. And today's question is question number 3 from the long answer section. Derive the kinematic equation of motion for constant acceleration. Before moving on to this derivation, we need to know one formula in each of the topic. The first formula that you need to know in integration is basic formula integration of x dx. X power n dx, which is equal to x power n plus 1 by n plus 1, where n is the power, okay, or exponent. Now, for example, I will give you an integral x power 6 or x power basic. I'm going to give you a basic example, x power 2 dx. You need to integrate this. If you are given an integral question like this, then you need to apply this formula. You need to apply this formula, which is x is the same as in the formula. In the place of n, you're gonna put 2 and add it with 1 and divide it with 2 plus 1, which is x cubed by 3, or you will write it as 1 by 3 into x cubed. Now, in integration, there are two things in an integral symbol. One is your lower limit, and the other is your upper limit. Lower limit and upper limit is nothing but it is similar to starting point to final point. So this is your starting point and this is your final point. Now, if in your example my lower limit is 1 and my lower limit is 0 and upper limit is 2, then how will you evaluate this limits in the final obtained answer? You will take the x value in square brackets and write the upper limit 2 here and lower limit here. Now you're going to substitute 2 and 0 in the place of x, which is 1 by 3. In the place of x, you're going to substitute 2, so 2 cube. You will subtract 0 cube from 2 cube here. So this is what substituting the limits in x value means. So now after solving this, what you will get? 1 by 3. 2 power cube is 8 minus 0 cube is 0. So you will be left with 8 by 3. So my answer for integral 0 to 2 x power 2 dx is equal to 8 by 3. So this formula is important in this derivation. And the other formula which is important for this question is in differentiation, which is also the basic formula in differentiation. Differentiation of x power n. Now you're going to differentiate this x power n with respect to x. For this differentiation, we have a formula called as n x power n minus 1. The power will come into coefficient and the power will get reduced by 1. Now I'll give you an example. Differentiate v square with respect to v. So what you will do, you will apply the formula. Here in the place of x, my example is v. So I'm going to write v. My n value here is 2. So here by applying the formula, I get 2v. You need to subtract n. You need to subtract 1 from n. So 2 minus 1, which is equal to 2v power 1, which is nothing but 2v. So when you differentiate v square with respect to v, you get 2v. So this is your integration, this is your differentiation, and this is your integration. So you need to remember this formula. You need to remember this formula and this formula for this derivation. These two formulas are very important in order to learn this question. So moving on to the question. So I have divided the board into 4 parts. If you're taking notes of this class, please divide your page into 4 parts and write the following headings. The first heading is velocity time relation. The second topic is displacement time relation. The third one is velocity displacement relation. And finally, we'll get all the kinematic equations. So each equation that we obtained in each 3 of the topics, we will be combining and writing in this part. So let us start with velocity time relation. Now, what is acceleration? Acceleration is defined as the first derivative of velocity with respect to time, or change in velocity with respect to time, or rate of change of velocity. So we write A is equal to delta V by delta T, or we represent it as dV by dt. Okay, so we represent acceleration as A is equal to dV by dt. So this is the expression that we can get from the definition of acceleration. So acceleration is defined as the first derivative of velocity with respect to time. Now I'm going to rearrange this equation. I'm going to bring this dt or transpose the dt to LHS. I'll get it as dV is equal to A dt. Now I'm going to integrate this. So before obtaining our integral formula, let me assume, before all these steps, I need to assume that an object is moving along a straight line. An object is moving along a straight line at time t equal to 0. At time t equal to 0, my initial velocity is u. My initial velocity is u. And at a later time t, when my time becomes at some time t, I don't give any value for it, but when at a certain time, at a later time, my final velocity will become v. Final velocity will become v. So an object is moving along a straight line. At time t equal to 0, my initial velocity was represented by u, and the final velocity of the object that is being moved in a straight line is represented by v. So my velocity, the integral related to the dv, will have a limit always from initial velocity to final velocity, and the time interval is 0 second to t, right? 0 second to a time t. So my integration limits for the integration a dt will become 0 to t. Now I'm going to apply the formula that we saw before the beginning of this topic, that is integration of, write in another color, integration of x power n dx is equal to n x power n plus 1 by n plus 1. So I'm going to apply this formula here. Integration of dv is what? Always integration of a constant and a derivative will always be kx plus c. I'm going to apply this into this equation, which will be nothing but, when my constant here is 1, so I will get, when I integrate this expression, I will get 1 v plus c. So I will not take that c, because I will have it like integration of dv will be v. Since you have limits to solve, you will enclose this v in a square bracket and write your limits. Now you will integrate this a dt. If you have a constant inside an integration, you can remove that constant outside of the integral symbol, which is a integration of 0 to t dt. Integration of dt is t. So now you are going to apply the limits for this. So v minus u is equal to a times integration of dt is t. So you will enclose this in a bracket and write the limits t0, which you will have v minus u is equal to a into, you will apply the limits for t and you will get t minus 0, where you will have v minus u is equal to a into t, because t minus 0 is t, and when you multiply a with t you will get at. So v is equal to, now I'm going to transpose the initial velocity to the right hand side, so I'll be having u plus at. So my final velocity is equal to u plus at. So this is one of my equation. I will take this equation as equation number 2, and I will take this equation as equation number 1. So this is my first kinematic equation. So I'll write it here. My first kinematic equation is v is equal to u plus at. I got the first equation. Now more 3 equations are left. So I'll move on to the second topic, which is to find the displacement time relation. So these are formulas of integration. Now in displacement time relation, we are going to see the definition of velocity. The velocity of a body is defined as the first derivative of displacement with respect to time. Acceleration was defined as the first derivative of velocity with respect to time. Then velocity of a body is defined as the first derivative of displacement with respect to time. Here displacement is represented as s. So first derivative of displacement is ds by dt. ds by dt is equal to v. Now I will now what I will do here is, in the place of v I'm going to substitute u plus at. In the place of v I'm going to substitute u plus at. So I will have, before doing that I will transpose this dt to the left hand side, so that I get ds is equal to v dt. Now in the place of v I can substitute this second equation, where I will have ds is equal to u plus at into dt. Okay. Now when I multiply u with dt, I will get u dt. So ds is equal to u dt plus at dt. When I multiply at with dt, I get at dt. Now I'll integrate all these terms. I can integrate all these 3 terms. So I'll take integration of ds is equal to integration of u dt plus integration of at dt. Since I am going to integrate the derivative of time, my limits will be from 0 second to t seconds. 0 second to t seconds. Here my displacement will be from 0 to s. Now I'm gonna have to integrate this. So integration of ds is always s. So I'll apply the limits here, 0 to s. U can be taken out of the integral because u is a constant here. So I'll take u outside and integrate dt. So integration of dt will be giving you t. So I'll write t and I'll write the limits t to 0 to t, plus a is a constant here, so I'll remove a, and now I'm going to apply this formula. When I apply this formula for integration of t dt, 0 to t, my limit is from 0 to t. My x value is t and my n value is 1. So 1 plus 1 by 1 plus 1, where t square by 2. Or I can write it as 1 by 2 into t square. Since I need to apply the limits, I'll take 0 to t, where I will get 1 by 2 into apply the limits. In the place of t, I'm going to substitute t. So t square minus 0 square, where you will be left with 1 by 2 t square. So this will be your answer here. So now when you integrate t dt, you will get your answer as 1 by 2. So I will write it as a by 2 t square. Is it right? I'll continue with the limits. So when you apply the limits for s, you will write it as s minus 0. Upper limit minus lower limit is equal to u times upper limit minus lower limit plus half at square. So now you got s minus 0 is always s, which is equal to u into t minus 0 is t, So when you multiply u with t, you will get ut plus half at square. So this is your second equation. So the second kinematic equation that I have arrived using displacement time relation is S is equal to ut plus half at square. Now I'm going to substitute the first equation in that of the second kinematic equation. Now let me have this equation as equation number 3. Now from equation 1 I can write. Now I'll erase this rough work. At square can be written as how? How can I write at square in other form? I can write it as at into t. When you multiply at with t, you will get at square. So now I'm going to separate that at square into at into t. So I'll write s is equal to ut plus half at into t. So now in the place of at, I'm going to substitute v minus u. So after substitution, what will I get? S is equal to ut plus half into v minus u into t. Now I'm gonna take this rough column, but you need to mention while solving this equation. Since I don't have space downwards, so I'm gonna continue here. So the continuation of this is here. S is equal to ut plus half at half into v minus u into t. Now I'm going to multiply this v with t and u with t, so that I'll have s is equal to ut plus half into vt minus ut. Now I'm going to multiply this half with vt as well as with ut. So I'll be having like s is equal to ut plus half vt minus half ut. What is 1 minus half? The answer is half. So if 1 ut minus half ut will give you half ut. Therefore, when you add half ut and minus 1 by 2 ut, you will be left with 1 by 2 ut. So you will write the final equation as s is equal to half ut plus half bt, or you will just take common. 1 by 2 is common as well as t is also common. So s is equal to 1 by 2 into ut plus bt. Again you will take common value t. So s is equal to 1 by 2 u plus v into t. So this is my third kinematic equation. So according to our book order, it is actually the fourth equation. So I'll write it as fourth. 1 by 2 u plus v into t. It is equal to yes. So for the third subdivision, I need a little space. So continuing with the third part of the derivation, which is velocity displacement relation. Now, in the starting step, I'm going to take the first definition of my first step related to this question, which is the definition of acceleration. What was my definition of acceleration? Acceleration of a body is defined as the first derivative of velocity with respect to time. So I take my acceleration is equal to dv by dt. Now to this equation I'm going to multiply and divide by ds. Multiply and divide by ds. ds by ds. Now I'm going to cross divide it. That is, I will divide dv by ds and I will divide ds by dt. Okay, which will give me a is equal to dv by ds into ds by dt. ds by dt. What is ds by dt? From our displacement time relation, the first step of displacement time relation was the definition of velocity. Velocity of a body is defined as the first derivative of displacement with respect to time. So I'm going to use that definition, and in the place of ds by dt, I'm going to substitute v. So A is equal to v dv by ds. Now I'm going to rearrange this whole equation. I will transpose this ds to the left hand side, so that I will have ds, and I will transpose this a to the right hand side, which is v dv by a. ds is equal to v dv by a. Now, before all these topics, we learned two formulas separately in the beginning of the video. That is, one for integration and one for differentiation. In the differentiation part, we learned a formula as d of x square, or d of x power n is by dx is equal to n x power n minus 1. You learned this formula, and I gave an example for that question, for that formula. So I'm going to use that topic here. The example that I gave you for that definition in the starting of the video was differentiation of v square by dv. Now I'm going to use this differentiation of v square here. What is the differentiation of v square? You're going to use this formula. My x value is v and my n value is 2, so I'll write here 2. So 2 times v, and in the exponent the power will become n minus 1, which will be 2 into v power 2 minus 1, which is 2v, right? So this dv square by dv is equal to 2v. I'll bring this dv to the right hand side, which will be dv square is equal to 2v dv. Now divide both the side by 2. Divide both the side by 2. When you divide this equation by 2 on both the side, you will get 1 by 2 dv square is equal to v dv. You arrive at this equation, and you have v dv value as 1 by 2 d of v square, and I have a value in this expression v dv. So in this place, in the place of v dv, can I substitute this expression that I have obtained here? Yes. So now in the place of v dv, I'm going to substitute this 1 by 2 dv square. I'll write in the rough column, that is v dv is equal to 1 by 2 dv square. So this is the equation that I have obtained from this rough column. What I did, I took the differentiation of v square and I arrived at the equation for v dv. Now I'm going to substitute the value for v dv, that is ds is equal to, what is the value of v dv? 1 by 2. 1 by 2 in 1 by 2a, because multiplication in the denominator is same. So 1 by 2 into a is 1 by 2a into d of v square. Now I'm going to integrate this. I'll write ds is equal to 1 by 2a d of v square. I'm going to integrate on both the side and apply the limits. If I apply the limits, what will be the limits? For s, for ds, the limits will be 0 to s, and for velocity, my limit will always be initial velocity to final velocity, because the object is moving on a straight line where the velocity at time t equal to 0 is called as initial velocity, and the velocity at a time later time t is final velocity. So starting point is u and ending velocity is v. So it starts from u and ends at v. So now I'm going to integrate this. If I'm going to integrate this, how will I do this? Here I have a constant, so I'll remove it out of the integral symbol, where I will get 1 by 2a integration of u to v d of v square, and integration of ds, and you will apply the limit 0 to s. Now integration of dx will give you x, and integration of d of x is x. Now in the place of x, if we substitute integration of d of x square, what do we get? X square, because any value in the place of x will give you the same answer as it gives for x. So now I have integration of dv square. What will I get if I integrate that? 1 by 2a. Integration of dv square is v square. Since I have limits, I'm enclosing it in a square bracket and I'll apply the limits u to v. And integration of s is always integration of dx is equal to x. So integration of ds is s, and I will enclose it within a square bracket where I will get 0 to s and apply the limits. After applying the limits, I will be getting s minus 0 is equal to 1 by 2a. In the place of v, I'm going to substitute v square, minus in the place of v, I'm going to substitute u square, where s minus 0 is s, 1 by 2a, v square minus u square. Till now, I didn't arrive at the final equation. Now, if I simplify this equation, I will get my final expression, which is I will take this 2a to the left hand side, where I will get it as 2as is equal to v square minus u square into 1. V square minus u square into 1 is 1. V square minus u square times 1 is v square minus u square. So now I'm gonna bring this in terms of v square. So when I bring this in terms of v square, I'll write v square is equal to u square plus 2as, because I am bringing this u square to the left hand side, so that minus will become plus, and I will get my final equation as v square is equal to u square plus 2as. So my third kinematic equation will be u square plus 2as is equal to v square. So my four kinematic equations are v is equal to u plus at, s is equal to ut plus half at square, u square plus 2as is equal to v square, and half into u plus v into t is equal to s. So in the next video, we'll be learning about the fourth question of the long answer. Thank you.